Hi, we are from group 13. We're gonna talk about the point load test. Main purpose of carrying out the point load test are to obtain the point load strength index and unconfined compressive strength of core rock specimen or irregular rock fragments. Point load test do not require costly specimen and preparation, and it is a quick, simple test. Failure load P and the distance between patterns D are measured to obtain the uncorrected point load strength P over D squared. A correction is applied to account for the specimen size and shape, and the unconfined compressive strength is obtained from a correlation equation. Depending to the specimen geometry, three types of tests can be performed: diametric, axial, and irregular lump. It is suggested by ISRM 2007. So this is the picture for each requirements. For the A specimen, it requires the diametric test, and for the B, it requires axial test, and for the C, the block test, and D, the irregular lump test. The objective of point load test is to determine the compressive strength of rock specimens from irregular lump test. For theory, when first introduced, the point load test was used mainly to predict uniaxial compressive strength, which was then established test for general purpose rock strength classification. Point load strength now often replaces the uniaxial compressive strength in this role, since when properly conducted, it is as reliable and much quicker to measure. The point load test should be used directly for rock classification, since correlation with uniaxial compressive strength are only approximation. On average, uniaxial compressive strength is 20 to 25 times point load test. However, tests on many different rock types, the ratio can vary between 15 to 50, especially for anisotropic rocks. So the errors of up to 100% are possible in using an arbitrary ratio value to predict compressive strength from point load strength. The point load strength test is a form of indirect tensile test, but it is largely irrelevant to its primary role in rock classification and strength characterization. The point load test is approximately 0.8 times the uniaxial tensile or Brazilian tensile strength.
So for the procedure, first thing we need to do is to get an irregular shape of samples of specimen rocks. So we will assume that this is our rock specimen, and we will use the ruler in order to measure the dimensions of the rock. In the lab, we can also use a vernier caliper. After that, we need to reset the hydraulic bleeding gauge, and we take the sample of rock and put it in the pointed specimen right there, and we apply pressure on the sample rock until it breaks. After that, we record the maximum pressure of the rock can withstand, and the data which is obtained from this experiment is used to calculate the point load test. So the experiment should be repeated with different types of samples of rocks.
The data is as shown. The formula that we use is first average width, which is W1 plus W2 divided by 2. The second is area, which is width times diameter. The third is equivalent core diameter, which is 4 times area divided by pi. So the fourth formula is size correction factor, which is square root of equivalent core diameter divided by 50 power of 0.45. The fifth is for load from kilonewton to newton, which is the load in kilonewton times 10 power of 3. The sixth is for uncorrected point load strength, which is IS equals to P divided equivalent core diameter. The last formula is the real point load strength, which is uncorrected point load strength times size correction factor. So for the result, for test number 1, we got the average width is 31.99 the area is 787.59, the equivalent core diameter which is 1002.79, and the size correction factor is 0.8142, and the load in Newton is 8,000. So you will get the uncorrected point load strength is 7.98, and the real point load strength is 6.5 Newton per millimeter square. So the calculation continues for test number 1, number 2, and number 3.
For the discussion and conclusion for G43 point load test, this is the data and result for the sample 1, 2, and 3. And according to ISIM 2007, this is the classification of rock strength. And for the sample 1, the rock strength is 6.5, sample 2 4.16, and sample 3 3.93 Newton per millimeter square. And these rocks are in the range of 3 to 10, so we classify the rock as the very high strength. In conclusion, the objective of the experiment has been achieved, where the compressive strength of rock specimen for the irregular lump test is determined in the range of 3.93 to 6.5 Newton per millimeter square.
As for the experiments in G4, Part 1 and Part 2, which are core logging, Schmidt rebound hardness test, and also point load test, all objectives are achieved, which from core logging, we obtain the RQD values and also we know the description of rock. As for the Schmidt rebound hardness test, we obtain the average rebound value and also the average UCS value of the concrete. And as for the point load test, we obtain the compressive strength of rock specimens from irregular lump test. That is all from Group 13 for G4 lab session. Thank you.